Hi, everyone, and thank you for joining us for today's webinar, the next in the ATA webinar series, where today we're going to be looking at all of the exciting new features and enhancements in Femap 2301. My name is Jonathan Hill, and I'm based in ATA's Northern Virginia office right outside Washington, D.C. I'm really excited to be joined today by Andy Haynes from Siemens Digital Industry Software. So I will turn things over to him in just a second. Before I do that, I want to give just a quick overview of ATA so you know a little bit more about who we are and how we might be able to support your team in the future. So ATA Engineering has over 40 years of experience providing high-value engineering services, primarily focused on test and analysis-driven design. Our engineers are passionate about helping our customers overcome their toughest multidisciplinary product design challenges across a wide range of industries, just some of which are shown here. As a company, we are an employee-owned small business, and we have a full-time staff of about 200 that's distributed across 7 nationwide offices. Our expertise is in mechanical design, analysis, and test. And so we have decades of experience with everything from structural dynamics, thermal analysis, and vibroacoustics to fluid dynamics, multi-physics simulation, and more. We're also the leading independent modal test group in the United States. So we have a lot of expertise and experience, flying out to wherever the test article is, conducting a large ground vibration test or modal test, and then using those results to correlate our finite element models. We're also able to leverage our collective experience and expertise through our role as a Siemens partner and value-added reseller. So in that capacity, we can provide support for a number of products. That includes Femap, which is, again, the focus of today's presentation, but a lot of other really great tools as well, like NX and Simcenter 3D, Simcenter Nastran, Star CCM Plus, and many more. And most recently, the hardware and software offerings that are part of Siemens Simcenter Test Solutions. ATA is also the developer of the official Simcenter Nastran training material. So if you were to go to Siemens, for instance, and ask for, say, an Intro to Dynamics class, you end up usually at an ATA office with an ATA instructor. And again, we develop the material. So we have, again, just a strong background with Nastran and all things dynamics. And then also our engineers, I was just talking about all of our experience. Those engineers are the same ones staffing our technical support hotline. So you can have confidence that when you run into problems, you can reach out to us. You'll be connected directly with someone who's probably had that same problem and figured out how to get around it. So just wanted to mention that about our hotline support as well. And a final thing before I turn it over to Andy, I just want to encourage everyone to check out our website after today's webinar. There's a lot of really good content out there, everything from upcoming calendars of training classes and future events. You can contact our technical support hotline through the website if you don't want to call in. And probably the best part is just all of the free resources. So we have a lot of APIs and white papers and other on-demand webinars. So feel free to check those out. And also feel free, if you look at that and feel like there's something missing or there's something, an API that you're looking for or a topic that you'd like to learn more about, please feel free to also reach out to us and let us know, because we're always looking to you guys for inspiration for those future topics. With that, though, I will turn things over to Andy. Thanks.
Thank you, Jonathan. Let me just get this shared with everybody. Hopefully everybody can see it, and now we can get going. So again, today's topic is what's new in Simcenter Femap 2301. I'm Andy Haynes. I've been with the with the Femap development team since 1998. So I've been here quite a long time and done basically everything other than physically write the software itself. So here, without further ado, let's just kind of get going here. So just here's a little bit of a roadmap. So what we're talking about, obviously, today is Femap 2301, which we released in January of this year. And just so everybody knows, if you've gotten if you've gotten 2301 and ran into any issues, we actually released Maintenance Pack 1 last Friday. So basically, you can go to the Support Center website and get it. And honestly, if you are using 2301 right now, even if you aren't experiencing any issues, go get MP1. We fixed quite a few things in it and added a little bit of new functionality along the way. Just a little bit about, we're going to have another maintenance pack of 2301. Then we hope to release 2306, or whether we call it 2307, probably sometime in July. Then we'll have another release either in late December or early next year, which again, we're going to call 2401, or we might call it 2312. We'll cross that bridge when we get to it. And just notice that the numbering scheme has changed from being like the year and 0.2. We basically now the first two numbers are the year and the second two numbers are the month it was released. Okay, and this is just the agenda for today. I'm just gonna go past this and we're just gonna start talking about what's new. First thing is Teamcenter integration. So this allows files to be managed from within the Teamcenter environment. You basically can now go to this new PDM menu that we have, where you can go to Teamcenter and you can do stuff like sign out, open, import, and save, and we'll kind of get to those later. What we also added to this PDM menu was we had file share. That was a command that we had for 2022.2. We moved that over to the PDM menu. So the file share menu is now the PDM Xcelerator Share menu. And then we also moved file references, which was often confused with file preferences. We also moved that over into this PDM, which, and just so everybody knows, the references command was basically just a very simplistic version of PDM. All it really did was, check file dates to make sure they were the same. And if you had these things specified, you could then it would basically just prompt you to bring them in. So the way that Femap requires, Femap requires the Teamcenter Rich Application Client, or RAC, for implementation. So items actually need to be created in the RAC to use with Femap, but once they're created there, then you can do everything you might want to do. And just so everybody knows, obviously the RAC is not the easiest way to use Teamcenter. So we are certainly also going to do interaction with the Teamcenter Active Workspace for a future version. Probably, I'm not sure it's going to make it into 2306, but maybe, our next release after that. So again, you just basically, just save the Teamcenter, open from Teamcenter, just brings up, if you're used to using Teamcenter at all, just brings up familiar dialog boxes. And again, it allows check-in, check-out, allows you to track revisions and revision history documentation. You create a data set that actually hosts the Femap mod fem file. So like the Teamcenter save, allows the user to check the file in, and Teamcenter open allows you to check the file out. And one of the other kind of interesting things that came along with this was the ability to import a JT assembly from Teamcenter. So Femap uses the JT file that's generated by Teamcenter, and for each item revision to import the geometry. And this allows Femap looks at the BOM view revision, or BVR, to find the associated part IDs and subassembly IDs. So this essentially allows you to create, I shouldn't say create, import into Femap what some people call the assembly JT or the shattered JT file, which was a sticking point, because even though we were able to import JT geometry before just through import file geometry, this is a very specific format. But again, if you're trying to import JT files that have been saved in this format in Teamcenter, this is how you would do it. You would just use this PDM Teamcenter import JT assembly. So again, this was just a first implementation, so we're really looking forward to getting it, even more integrated moving forward. Just a little bit about some geometry commands that we did. Essentially, we ran into some issues just when we were doing our automatic mid-surfacing, where sometimes you might not need every tiny little hole. So instead of you having to delete those from your solid geometry, we just basically we had an option that's just remove holes. So essentially the mid surface it creates, it's just going to remove holes loops, slots, etc., from the mid-surface geometry, and then you can project down and burn curves in to make holes that you want in your actual, in your idealized geometry. Another one that was kind of odd is that if we didn't get a perfectly or properly trimmed mid-surface from our mid-surface automatic command, there were times where we were just throwing that out because it was not trimmed, the way we thought. So what we're doing now instead is if you turn this option on, we're just going to keep that around. And again, then you can slice it, burn curves into it, and just have it, because that's a whole lot better than not having any mid-surface geometry at all. So here we go. This is just kind of some original geometry, sort of just the bottom of a wing skin. So basically, here's what you get if you don't, if you have the remove holes option turned off. If you have it turned on, basically you just get the outline. And then something else here is this is the keep untrimmed mid-surface option, with it turned on. So basically you can see the original geometry on the inside, but we're actually creating this larger kind of untrimmed mid-surface. So again, from there, you could just take any of those curves, imprint them on, delete the extra, and get exactly what you want. So it's just kind of more of a manual. It allows more of a manual process, even though you were able to get the main mid-surface from the automatic command. Just some other things, just kind of miscellaneous. We now read points in from CATIA 4. In the meshing toolbox, we were always able to move parasolid points around, so like on parasolid geometry. But if you had curves that were created in Femap, kind of like a wireframe geometry, that was still done with the Femap standard geometry engine. So we just basically made the various tools that were able to move points in the meshing toolbox be able to update those points. And if the points were used by more than one curve, it's going to update all those curves in the background, and it's going to automatically update your mesh as well. And just some other options here, basically with like group curve from node and group surface from node. Again, these were just, we made these work with non-parasolid Femap geometry as well. Again, these were only working with Femap, with parasolid geometry. And we also made the selection methods that kind of equate to these group commands. So the commands that come up in the standard meshing, the standard entity selection dialog, basically these now also work with the our standard geometry engine points and surfaces. From a pre-processing standpoint, we did a lot to add element addition and remove. So element add remove. So this essentially allows you to create element addition and removal instances when you're using Simcenter Nastran Solution 401. These are created using model simulation in these element add remove. And there's also commands or via, you can use the command, or this is available via the model info tree. So you can actually make both element add remove entities or element add remove sets, which simply reference multiple entities. And what these are actually going to do, just in terms of what they're going to do for Nastran, is they're going to create ELAR, ELAR2, and if needed, the ELAR add entities in the Nastran input file. So basically what you do with a lot of our simulation entities that we've created lately, it just brings up a manager. So basically it just allows you to make a new entity, make a new set. You can edit the selected one show. You can convert from an ELAR to an ELAR2, and we'll kind of get into what that is. And then, or you can go the other way, basically. And it's basically just whether you want to have it be like kind of one value for all the elements you selected, or if you wanted to be able to select, 5 elements and give it one value, select a few more, give it another value, and you'll kind of see where we're going with all this. Then just delete, copy, and renumber commands. So you have a bunch of different criteria. I shouldn't say a bunch. I mean, you have 3 different criteria for element add remove. You can have it based on time. You know, when the time hit, when time hits, it's either added or removed. You can have it, hey, if it hits a certain inelastic strain, then the element will be removed. Or if it hits a certain mechanical strain, then it will, then that element will be removed. We have 2 options. So ELAR selected elements all use the same value. So you can either pick a group for this. So you just set your time. Like in this case, we're using time up at the top, and you can see that removals available. So time just at 0.5 of your analysis, you're just picking an element group or an element list, and all those elements that you pick are going to be removed at 0.5 time. Something else you can do though is if you just wanted to use individual values to be specified for each element, and then you get this nice table down at the bottom. So basically what you do is you use that icon on the left to pick which elements you want, and then you can always highlight ones from the list. You can remove ones from the list. You can completely reset the list. And then you even have some options in here with checkboxes, whether you want them to be removed or you don't. So it's basically just all down there in a table format, which you can then use. And in this case, you can also do some there's no delta time up there. So you can see we're using mechanical strain up here. So you just have a strain value. Hey, once it hits that, again, I want my element to be removed. And what does that allow you to do? That basically allows you to do what we have here in the beginning, which is basically, you could make like a pipe that cracks, basically as it, either you can think of it corroding a little bit, and then, at some point, the final one breaks loose, and then you really get into some large deformations and that sort of thing. So let me just get back to where we were. Okay, so right now you can only pick one of these element add remove per analysis set, but what you can do instead is you can actually make a set of these. So in a set basically creates the ELAR add, and then you can just choose that in your boundary conditions, and that'll allow you to choose any number of these available inputs. So basically, this just works like a lot of our other commands where we make sets. Essentially, you just have available inputs, and then you can just put them into referenced inputs, and then you can create sets like that. And what these are then chosen in the analysis set manager, just in the boundary conditions dialog box. So instead of choosing an individual item or entity, you end up choosing an element add remove set. Just something on the Aero spline enhancements. For a long time, ever since we added the ability to create Aero splines, we just always made you pick kind of which Aero boxes you wanted to include, basically, based on the C Aero ID that you have chosen in the structural grid group. Well, I shouldn't say based on the structural grid group, just simply on the C Aero ID. What you now have is you can just say, hey, I want to include all the boxes on C Aero ID, in this case 1. Or if you still want to do custom and only choose a subset of those, what you can do is you can go to custom, and then you can just pick boxes from the screen, Aero boxes from the screen. So, I mean, but the default is now to use all Aero boxes. Now, if you are importing a model from before this will always be set to custom, but you can always just come in here, edit, go to all boxes, and then it'll work the new way. So that's just something to keep in mind. Just on connection properties, we added quite a few things to the multi-step structural 401 tab. So, you can choose your contact algorithm. You can choose like whether you want to do closed gap tolerance, no separation. And then we also we added something to the more options dialog, which was the stiffness stabilization, which I believe used to actually be on this, but we actually moved it over into the more options dialog box. And then you can see we added quite a few things to the more options for solution 401, and they basically all have to do with friction. And so they're just over there in their own section now. And then we also added just the ability to toggle on the adjustment tolerance, because maybe you want to use it, maybe you don't. But basically this just allows you to turn it on. Basically, if you had it defined before, it was just always going to be used, and it also now accepts negative values. Just a little bit more about solution 402 then. This is the multi-step kinematic tab. So we actually added a more options button to accommodate some new options. And then we moved some from the main dialog box here to more options. And now again, and then we just added a bunch of new parameters for when you're creating the BCT par 2 for solution 402. And there you can just see that, you know, there's just a list of them. Kind of some interesting things here. Like we updated the group operations condense command. What the condense command always did was it took the rules in your group and it just converted them to ID rules. But what it would actually do though is it would convert the ID rules. But like even if IDs didn't exist in your model, it would throw those into the ID rules of that new condensed group. So now basically the condensed group only contains IDs of existing entities. Kind of along these same lines, but maybe even better than using condense is that we just now have the group operations reduced to existing. So this works a lot like condense, but it updates each rule type to contain its existing entities only. So it doesn't. So just to be clear, it does not condense the rules down to the ID groups. So the user retains the same functionality in original intent of the group. So if new entities get added and that sort of thing, it'll then get added to that reduced group based on those rules. So again, just kind of a neat thing. Maybe something we should have had, you know, for a long time. Also, just this is more of a bug fix, but we're calling it an update. Was if you had automatic add-on and then you renumbered to new IDs, basically the old IDs would remain in that group that had automatic add-on, and then the new IDs would also get added to that group. So then if you actually were to do something later where those original IDs were used, they would end up showing up in the group as well. So basically what it does now is it basically just takes those existing IDs, and once they're renumbered, it removes those from the group that you're automatically adding to, and just puts the renumbered IDs into the group using automatic add. Just a little bit more, you know, we updated how constraint equations are shown in the data table. Again, almost more of a bug fix, but you know, certainly is going to be a lot better for you now. If you ever took a toolbar command, say something that changed states that had like a little menu. So if you took those commands and you moved them over onto either your own or an existing toolbar, when you click them to kind of change the option, it would never change actually never change the icon on that custom or existing toolbar where you placed it. Now that works. And just added, you know, just in the standard selection dialog, we just added both 7 other and 8 fluid as material types, so you can just choose by those 2 material types now if you happen to have those in your model. A little bit about meshing. So we've had mesh points, you know, mesh hard points, whatever you want to call them, created via the mesh point editor dockable pane. So they're now recognized by the body mesher. So when using the mesh bodies command or when using the mesh geometry surface command with the mesher set the body on mesh. So basically, this was sort of an oversight, you know, from when we originally added the body mesher command. So basically, this works now, and I will tell you there was a bug in 2301 where if you turned on the all geometry option, it would not find the mesh points, but that's one of those things that was fixed in 2301 MP1, which again is available from Support Center. We also added a midside nodes tab, adding to the mesh bodies command, and basically this just does what the midside nodes sections of our other meshing commands do. Basically, just takes midside nodes that are created and it moves them to the geometry, and then there's a tolerance. So let's say like, hey, if it doesn't distort my edge of my element by more than 10 degrees, I want it to be moved to the geometry, but if it does, that might kind of skew my element a little bit to a way that I don't want it, or maybe it'll even cause some sort of failure, but that's up to you. So we give you a user-defined tolerance. So you can just see, it's basically just points recognized by that, and kind of just zoomed in on a single mesh point. Now this is some very interesting new stuff. So again, if you're not kind of up on newer versions of Femap, we added a mesh on mesh command in, I believe it was 2021.2 or 2022.1. I can't remember these days. But what it does is it allows mesh containing line element stiffeners to be completely refined or unrefined as you use this command. So the line elements tab actually controls if the adjacent line elements should be treated together or individually during remeshing. When they're treated together, that's when this actually can work the way I'm about to show you. But again, it's based on an orientation. So there's an option, and then there's also an orientation offset deviation limit angle kind of along the edge again. So that's sort of what tells it whether you want it to treat line elements kind of as one, or if it's outside of the sorry, if it meets this tolerance, it's going to treat line elements in a line kind of as one, but if it's outside of this tolerance, it'll treat them individually. So you can just see on the original model on the right, what we have here is you can see that if you refine the mesh, now those line elements are getting refined with it. Before, if those line elements were there, it just didn't get refined at all. So like in a place where you just have sectors or sections or whatever you want to call these areas, it would never update that section, where the shell elements actually ran into the line elements. So you can see on the left, you can now make a refined mesh, and again, it's going to refine your line elements, or you can actually unrefine your mesh, and then it'll just give you less line elements. So it just allows you to do both. So just some really interesting functionality, and that's one that we got from just like a symposium event. So just you might hear that we have some coming up later this year. Just if you're actually been using the mesh sizing command, we now get or the mesh control explorer pane, and this really only works with the mesh control explorer pane, so we're going to focus on that. Basically what we added was this auto close imprint gaps option. So when this is on, it's going to extend projected imprints to the closest edge when the distance from the end of the imprinted curve to the closest edge of another surface is within the tolerance. This is not meant, by the way, this is not meant to let's say you have a 10 by 10 surface. It's not meant to extend your imprinted curves like an inch in both directions or anything like that. This is designed for very small gaps, and that's when it's going to be used best. If you go instead and use the specified tolerance and you make it too large, I mean, you're just not really going to get much out of it, in terms of what you will when you're using the smaller gaps. So that's just something to think about when you use that. Certain people have tried to use it, and they're just trying to extend curves a very long distance, and then it doesn't know what to do with that. Then basically, I don't want to say it doesn't know what to do with it. It doesn't do anything special. It's just basically like you put a curve in there any other way that you could in Femap. So it's just, and it doesn't automatically suppress the curves or anything of that nature. So just keep that in mind. Just added it, just updated the mesh geometry preparation command. So it just asks you so I'm just going to start with the example here. Let's just say you have like a hollow tube with closed ends. That actually leaves you a pretty large void in the center. There was an option to suppress internal voids. So now now we basically think, well, I mean, you probably did not want to suppress this giant void in your, in your tube that just happened to have closed ends. So we just ask you a question. And if you say yes, it's still going to suppress it. If not, it just won't do anything. The mesh hex mesh bodies, we just, if you had some very specific, and if you haven't used newer versions of Femap, mesh hex mesh bodies was a command that we did add for 2022.1. It's basically just a hex dominant automatic hex mesher, and it basically kind of allows you to not have to slice and dice, and create sweepable, extrudable, revolvable sections. It'll just take it and it'll put as many hex and wedge elements in there as possible, and then where it has to, it'll fill the rest of your body with tetrahedrals and pyramid elements. But again, it's basically, you now just don't have to slice anything, but if you do slice it up, that'll certainly work for you as well. And it automatically matches mesh between multiple solids. So it's just really neat technology that we got from another piece of Siemens. And then just a little bit of an update on cohesive meshing that'll just kind of allows you to use it in more areas than you could before. Performance improvements. So this is just kind of a long Femap story, but we're going to kind of get down to brass tacks here. Essentially, we have two pipelines of graphics: performance graphics and original OpenGL. If you turned on best possible or performance graphics on the graphics tab of file preferences, then it was using what we call performance graphics, which were just highly superior in a lot of ways to our original OpenGL implementation. Drawback to this was, of course, having two different pipelines, and certain entities just did not work, like certain transparency, line weight, line pattern, things of that nature, fill style, just didn't work with supported graphics. In the interest of making this better, we've actually, across all aspects of Femap, we did this unified graphics architecture, which now uses a single implementation and will be implemented over the next few releases. Essentially, you just turn on that unified architecture option that is highlighted there in the picture. And when it's fully implemented, UGA, UA, whatever you want to call it, will provide a better experience for the user in quality, performance, hardware support, and both the performance graphics and original OpenGL pipelines will be removed completely from Femap. So you'll never have to worry if it's working here, why isn't it working here, etc. If it's not working in the new one, it's just it should be. So just keep that in mind. So again, stuff like line style, line width, fill style, transparency will work here. Now, the first implementation of this is coordinate systems, geometric entities, so points, mesh points, curves, composite curves, surfaces, boundary surface in solids, and still the old Femap volumes, but that's going to be removed in a future version, probably our next one, just due to, through some telemetry and that sort of thing, and just questions and answers. No one seems to be using our standard Femap geometry engine volumes anymore. And the other thing that is also supported with the unified architecture is geometry-based loads and constraints. Something else to remember about this is that you can still use best possible and unified architecture, or performance graphics and unified architecture at the same time. So, you should get, kind of the best of both worlds. Now, I will say there were quite a few bugs with unified architecture, which caused some issues. So again, this is if you have 2301, go get MP1, and if you don't have 2301, just don't even go to 2301 at all. Go to 2301 MP1. And these are just some, kind of other miscellaneous performance improvements. So just, especially if you're dealing with the new convergent bodies from Parasolid, you might see almost a 50% speed improvement. If you have some very complicated faceted geometry, and just just updating columns in the data table API, we just gave it a 33 times speed improvement, and that and again, that's one of those things that somebody mentioned probably during a symposium type event, and we just took it home, and it went from taking 19 minutes and frustrating people to now it takes 34 seconds. So those are the type of performance improvements. All we need to know is that it's not working properly. So even if you run into something like this, you can report it to ATA, and they'll let us know, which is great. Analysis and solver support. So we made several enhancements to the monitoring and recovering results from analyses, which were launched within Femap. So basically what we're really talking about here is using Simcenter Nastran. So let's just say you use the analyze multiple command. essentially, if you have like a green square, the analysis is running. If you have a red square, the analysis is in the analysis queue and has not been run yet. If you get a green thumbs up, the analysis completed successfully. If you get a red thumbs down, the analysis did not complete successfully. So you just get some visual cues in the model info tree indicating what happened for a certain analysis set. Also, just we added something simple to the analysis to the analysis monitor, which is we actually show which set is there, the active set. So, and what's nice is that you can actually change the analysis. The analysis monitor will now stay up, and you'll actually see on the next page we actually have a way to bring it back up, and it knows which analyses, which analysis set it was linked to. So when you click, so if you were to like double click, say on analysis set 2, it's just going to switch the monitor to show you what was in the monitor for analysis set 2. And then if you hit load results, it's going to load the results from analysis set 2 instead of just doing the most active one. So one nice thing about this is if you turn the analysis monitor pane off before, well, there was no way to bring it back up. So you can see that there's a command to do that now. And again, as you change which one's active in the analyses branch of the tree, it'll show you the what happened for that analysis set in the monitor pane. You can right now we stop running, but you can just right mouse click and say, hey, just continue running the analysis queue. So let's say you had 30 jobs queued up to run. If job 3 stops, you can just come in here and you can just say, hey, just continue. So then it'll solve as many of the rest of them as it can, hopefully the other 26, and then you can go back and see what happened in your one. So that's just an option that's there. There's also options just clear the analysis queue, and then that load results command was always there. Sorry, that load results, again, just whichever one is being shown in the monitor, that's the one it's going to load when you use that. And if you do this at the top level, you can actually have it load results from any number of it'll do it for all of them, or it'll do it from any number of selected ones. So that's what load results can do from the context sensitive menu. Just something for the super Nastrannies, super Nastran people out there who know the either the name or the solution number. Basically now we just give you a little bit of information. So like if we're in Simcenter Nastran and we're buckling, I mean, hardcore Nastran people are going to be, oh yeah, I want to do a solution. I want to do a SOL 105. So now that'll show up in there as well. And it all depends on the solver and the type, and just to, a little bit more, just a few more examples. Like if you have it set to, that you're doing a frequency response, a direct frequency, it'll say that it'll show you that you're doing a solution 108, or if you're doing a modal frequency, it'll show you that you're doing a solution, you're about to run a solution 111. And then it also, and we did this for all of our analysis programs and analysis types. So like there's just an ANSYS running normal modes. It's just going to say AN type, comma modal down there. So, just a little bit more for the person who's looking for the nomenclature of the solver. For Simcenter Nastran, they actually did some updates for the way they do response spectrum application. So the first thing is that we added support for RS supply bulk data, RSpecR, and RSP opt bulk data entry. And basically it just does all of this automatically. You don't have to do anything. And then we also, added support for the new modal combination methods, the CQC, the DSUM. That's one's actually, where factor is earthquake duration, the GRP, which is group, and then the rows modal combination method. And again, the factor there is earthquake duration. They did a little bit more that we haven't added yet, but we hope to add that for 2306, 2307, whatever it ends up being. Okay, if you're running MSC Nastran, we actually added options to the Nastran output requests that will have it write everything needed to generate the HDF5 file, and we'll kind of get into more of what that involves later. Depending on what the selected options are, it writes the MLD-PRM bulk data entry with the appropriate value for the HDF5 param. And you can kind of see, just depending on what you have selected, it just writes the appropriate value there. And then you get an HDF5 file out of MSE Nastran. Just some additions for multi-step nonlinear, just for in the boundary conditions, as I mentioned, we just added a drop down where you pick element, add, remove. Just some other options that where we changed some defaults, and then we just added some options for solution and convergence. Not really going to go into all this, very much similar for solution 402. We changed default, just to reflect the latest default in Simcenter Nastran 2022 or 2212, I should say. So again, just some multi-step control options in there, and then some other options for solution and convergence. And again, we changed default values again just to reflect what the new defaults are. Something that we added for Simcenter Nastran for solution 103 MP1 was we added support for subspace in the real solution method section. It was always there, for like MSE Nastran, but for whatever reason, Simcenter Nastran didn't support it, even though you could actually pick it for a frequency response. Well, anyways, it was just something easy, probably low-hanging fruit for them, so they added it. So we just basically allowed you to choose subspace in that dialog box now, and it writes, SUBS to the method field of the Eiger entry. A little bit about Abacus, just shell to solid connection for glued contact, support for the 13-node pyramid, which all of Abacus, they're just degenerate hex elements. You can now make RBE3 like interpolation elements, and just some other options there for Abacus. And for ANSYS, kind of a neat thing that we did was some of these models we were getting from ANSYS, instead of having a defined cross section or an arbitrary cross section, they actually had a meshed cross section where it was actually in the input file, where there was a mesh just on a plane that represented a cross section. So we added support for that. So when you read these in, it just stores that. So along with the beam property, and then when it goes out, it writes this meshed cross section out again, instead of changing it to a into an arbitrary cross section. So just one of those neat things. And we also added a lot of support to read in additional ANSYS APDL style inputs, which are often used in by ANSYS Mechanical, formerly ANSYS Workbench, and we're not supported in previous versions. These are, if you've ever used ANSYS, these are the commands that you would have used in what they used to call Prep 7. So post-processing, we added a new computed vectors functionality. What this does is it can be used to calculate, you can use it to automatically calculate vectors that may not have been calculated by the solver, but maybe you're interested in finding out. So essentially, you choose when to compute them, or you can just do, so it can be automatically when results are read or created, or now in existing output sets. So you basically, you also have two kinds. You have standard or user defined. We're just going to go over the standard ones first. So, here in the element results, plate solid principles and invariants, plate average, mid stress strains, bar, beam bar von Mises stresses. There used to be a preference for plate solid principles and invariants. That's the only one of these that's ever going to be on by default. And now instead of using the preference, you can basically just point to one of these. You can actually save like a computed vectors library. So you can actually just have that do it for everyone. And again, you can just specify that in the preferences. Here's a big one, was the plate solid failure theories. Max von Mises, max shear stress, more Coulomb stress, max normal stress. So essentially, you just enter some values to use. There's like that little 3-dot thing in button, and when you use that, it opens up this plate solid failure theory options dialog box, and you can just kind of put whatever you want. And this can often be used for that design safety factor for verification. If you want to do laminate failure theories, say on, Hill, Hoffman, Saiwu, max strain, and we can add more of these as we go on if needed. Essentially what, if you've created enveloped results, what you can do here is you can have it now just do these failure theories based on something like an enveloped, results output set. And then we also just made it a little bit easier to automatically, do envelope results like beam all locations, solid all locations, plate laminate all locations, kind of like apply summary, so you have that, or like plate top bottom laminate all apply. So essentially, you just have these things. So you can just turn these on and it's just automatically going to do that. So instead of you having to go into model output process and manually do these, you can just turn these on. And the other option we have here is we actually have a user defined tab. So, you basically can do a combine envelope or have it be based on an API script. So you can just set up your own computation, like, for combined output or enveloped output. And then you basically can just add it. And then again, you can just turn on these checkboxes on the right-hand side, whether you want them to be auto run or whether, when you're in automatically, when results are read or created, there'll be an option whether you want to auto run each one that's in here, or if it's now an existing output sets, there'll just be an option. And when you hit OK, and then when you say OK, it'll just do that after, when you hit OK. So you just have basically you can make linear combinations or RSS combinations, and again, you just pick and you just kind of pick vector IDs and using that standard dialog box that we can choose to do output sets and which output vectors you want. You can do the same thing with envelopes again, and these are really just set up so you can do kind of things that you've been doing for a long time, but you can just have them stored. Or if you want, you can actually have it run an API script. So you can actually have it like, especially if you have the auto run option on with like an API script. What you can do then is it'll basically just take an API script you wrote to compute vectors however you might have wanted to do it. And basically it'll just, if you have that auto run set, it'll just, as your output is created, it'll just automatically run that computation for you. Yeah, and then you can actually, if they happen to be order dependent, you can also move these up and down the list because it's just going to start at the list and it's just going to use all the ones that are selected to auto run. So if you need to say calculate the first one there before it calculates the second one, you can have it do that. So you can move these up and down the list. And again, the list just starts at the top and goes down based on what's selected in that run, auto run or run now, depending on what you have selected up top. So just some really interesting functionality. Data conversion, we just did, we used to have average max value, which was actually max absolute value, and min value, which was actually min absolute value. We basically now renamed the two to what they actually are, max absolute value and min absolute value. And then we just have new max value and min value options, which do not do an absolute value before they calculate the max and mins. And these were implemented just in all these different places. Contour options, post-processing toolbox for data conversion, view options for so these will show up in the post titles, the charting pane, dialog in the legend area, model output process convert tab, the output map data surface in the data surface editor, the model load map output from model command, the entity editor and data table, which contain info about the view, and then just in those two API cases as well. Now back to the HDF5. So Simcenter has its own version of the HDF5 file, which is called the SCD5. And the SCD5 is going to be kind of a standardized output file for a lot of different simulation products that Siemens DI is going, has. And basically, so let's just even say like you got output from Star CCM plus something like that. Eventually their data is going to be in the SCD5 file, and then we should be able to just take their output file, their SCD5 file, and then read the results directly in the Femap. As long as the mesh is the same, or we might even be able to do something where we would read the values from that and then automatically be able to say map those onto like a mesh that's not the same as the CD, as the star mesh. So now there's no way to currently request SCD5 file from Simcenter Nastran via the Femap user interface. So it's just going to create. What you can do is you can just have it create an OP2 file, and then you can run it through a converter that is shipped with Simcenter 3D, and we're going to start shipping that converter with Femap as well in the future. But the whole idea is you shouldn't need to use the converter. It's just, this is still kind of newer technology. That's just the way that we can do it now. But what we can do instead, I don't want to say instead, but the Nastran HDF5 file, the .h5 file, is quite a bit more mature than the SCD5 file. And so what you can do there is you can request those via that Nastran output request dialog box. Again, we now have the generate HDF5 options in the output requests. So what we're going to do is so you can just turn that on, and then what you're always going to have to do with SCD5 is you're never going to import it. You're always going to attach to the results when you're using these. So it's just file attached to results. But remember, you can always just save the data from an attached results file in the Femap, and then it'll be internalized. So you can certainly get to it that way. Now, and I'm not going to go through all these, but as you can see, we added quite a bit of support for the various output quantities in the H5 file from MSE Nastran. So those nodal, a lot of element stress results, including nonlinear. We even added, again, we just added some support for MP1 for a couple of new things like beam nonlinear and gap nonlinear. Composite stresses, element forces, element strains. And this is just something to remember about the HDF5 stuff that we've been doing. We needed to do a lot of stuff on the background in order to be able to read HDF5 files just from, just that. So we had to do a lot of that, but that's all done now. So now adding quantities is pretty easy. So, if you find that there's not a quantity, an output quantity that we're supporting, just let us know. And if you can, and by all means, if you can provide a simple model with that output in the HDF5 file, we can add it, like, I don't want to say in minutes, but like in an hour. So, it's certainly highly expandable that way. Oh, we also now support element addition, some specific results for element addition and removal. So preborn and removed element flag, and activate, deactivate element time. So basically, you can basically tell you whether it's been removed or, and then when it was removed. By the way, I did not mention this earlier, but you can only use time to add elements. You can't add elements based on inelastic strain or mechanical strain. So I just wanted to mention that. And we also added some support for various types of strain results for solution 401 and 402, specifically for axisymmetric plane strain and plane stress elements. These were just things that we just didn't support before, but now they're in there. A little bit about miscellaneous and API. Command finder. So a lot of other products you've used have a command finder. So we finally added the command finder functionality. Basically, you just type in what you want, and then it basically tells you the command where you can go find it. Now, not everything you find, not everything you might want to find is in the actual name of a command. So this is being expanded for 2306 or 7 to find stuff in toolbars, find stuff in the dockable panes, actually even recognize words that you might have seen in a different product. So like something like equivalence in Patran, it'll show you that, hey, you might be talking about like tools coincident, tools check coincident nodes or points or what have you. So that's going to be in there for 2306. So, and as we move forward, it's just going to get better and better each version, but now it's in there. So that's good. And then functionality, we just added API access to the computed vectors, element add remove objects for like our new group command. Also the mesh editing split command to access like the mesh editing split command programmatically you can now do. And just a couple of other things here, oh yeah, some new options in our mid-surfacing that allow you to choose, like, to turn on that remove holes or keep untrimmed surfaces, that sort of thing. And then just some other things. Oh, also, if you've ever tried to use the solid clean, it was like FE geometry solid cleanup. I forget what it was. It had way too many arguments to be able to use the advanced one. So we actually just created an object, and now you can just pick and choose which options you want there. And then it's basically an object, you just pick it, and then there's just kind of a way, then there's sort of a run, there's just like a run method in there to, run the actual cleanup command. And that's it. Yes, and now we have a Femap software as a service offering. So that's just an interesting thing to know. If there is a 30-day free trial that you can get from Femap. If you want to know how to find that, please ask the guys from ATA, folks from ATA. There it is. But it's okay. And then also, if you're looking for things, one place you can look, if you're especially maybe looking for hotline stuff, you can also, there's an online Femap community. It can be reached via our help menu. So you can explore the blogs, the forum, learn from the knowledge base. That's also, and a lot of this information is also just on our support center website. So, and now, okay, and now, and that's it for me. So let's get into some Q&A.
Awesome, thank you so much, Andy. That was great. We've had a lot of questions, so I will read those in a second. If you're out there, please feel free to keep adding questions in. Also, if you think we aren't answering your question well and you want to request permission to unmute, just drop that in the chat or the Q&A tab or something, and I can give you that permission too. But I will start running through some of those questions, and maybe first to just starting like really high level. There are so many like new features and little, things that just make workflows a little more efficient, but you don't necessarily catch them if you don't see every what's new presentation or dig into the documentation. And so, Andy, do you have any tips for, without having to go through every what's new version or sit in like a multi-day class, like what's the best way or any tips just to keep up to speed on like the latest, greatest and workflow stuff?
Well, I mean, the what's new document is always great. We also have a README that's issued with everything that's broken out into section by section. So, that's one way to do it. There's we typically make 5 or 6 videos for each version as well, that are available out on YouTube, and I can certainly send some links to that. I mean, those are the best ways. I mean, the what's new document only tells you what's new, really, where the README actually tells you both what's new and what we fixed. I mean, but those are what we have right now, and we've been trying to add more and more stuff to Support Center in the Learn and Explore section. So we've been trying to add kind of more specific things to there. A lot of those don't have to do with what's new. They have to do with more overall things. But I mean, watching a presentation like this is always a great way to do this.
Okay, thanks. Yeah, and I'll also add, like I think ATA would like to be doing more webinars, but just things like that, or we have a couple Femap symposia coming up later this year, and even just the little like demo sessions during those, I feel like just watching someone else drive Femap for like 15 minutes, everyone sort of comes at it in a different way, and so it's really interesting. I feel like you pick up on new things just watching someone else drive for a little bit. Cool, so thanks for that one. Question on Teamcenter. Do Teamcenter items need to be released for Teamcenter integration to work?
I really couldn't tell you. I mean, you know what, if you send me that one, I can certainly find out. And by released, what do you mean by that? Like an item is created then released somehow into the Teamcenter environment, or are we just talking about sign in, sign out?
I am not sure. Brendan, if you want to put more comments in the chat, or if you want to unmute, let me know. Brendan had another one too. I guess this is kind of going back to the first question. So if they were to upgrade from 2020.1 to 2301, are there any other major updates to be aware of? And yeah, I think it would just be go back and look at either ATA or Siemens webinars on what's new, or some of those little, like the little 2 or 3 minute videos, like Andy mentioned. There's been a lot of really cool meshing enhancements in the last couple of years. Sorry, Andy.
Yeah, no, I mean, that's really the only way to find out. I mean, again, you can look at you can certainly look at the various what's new presentations. Documents, you know, that sort of thing. But yeah, I mean, from what version was that? 2020.2 to 2301.
Yeah.
I mean, that's we basically almost completely revolutionized our meshing technology since in those releases. So including the body mesher, the mesh on mesh, and I mean, there's probably a better way to do it. We just if you have any ideas, we'd love to hear them. You know, that sort of thing. But yeah, I mean, that's why we make a what's new document. That's why we make the readmes. So, and the videos, and we've been, and we've made videos, I think, since 2020.1 or 2020.2, so you can kind of find out about them. We also have done these launch events, but those launch events only focus on maybe 5 things, whereas something like this, I probably explain 20 different things. So a launch event might only explain 5 high-level things. So those little nitty-gritty type of things, those are a little bit harder to find, but we do try to highlight those in those videos that we create.
Cool, thanks. Next up is a question on solution 401, and Brian notes, he understands the formulas that define nonlinear behavior, but a lot of times either the vendors don't have material properties, and like as individual analysts, we don't always have a way to measure the materials we're using. So just wondering if there were any tips on like quick and dirty ways to test, measure, and correlate with a model. Andy, do you have any? I have a couple ideas, but do you have any ideas?
No, I mean, we just always expect the people to have their material properties. I mean, if you need to go get them, there are various websites that you can subscribe to and whatnot to get those, to get that type of information. Now, we have been toying with the idea of being able to import certain files that have, material information. So if somebody did have that, but I mean, that's just not something that's like they're XML files and that sort of thing, but we just haven't gotten to that yet.
Okay, thanks. Yeah, and I'm not sure if Brian's focus was more on the like material characterization testing side of things, which I mean, it all varies based on the specific material type, but like that's one conversation, and then model correlation is another, and I don't know if that might be, it's probably application specific, but ATA has a program called Attune that we use for automated model correlation, so that might be another thing to investigate. I'm going to keep going through the questions. We've got a lot of questions, so thank you all. Andy, could you talk a little more about the HDF5 and the Simcenter version of that? I think there are a couple. I don't know if you can see the Q&A tab, but there have been a couple questions about just like what are its strengths, I guess, and just additional documentation on being able to.
All right.
Use. Sorry.
All right. Let's just start here. It's not fully baked yet, so there really are hardly any advantages to using it, but they are working on it all. So and they're working on, again, like a grand unified file for it. So there's really no reason to use it from Simcenter Nastran right now. The only reason that we even added support for it was just because we were adding it for MSC at the same time, and we needed to create the whole backbone for it. So, I mean, for right now, there's just not a whole lot of reason to try to use it. They still don't have all the conventions figured out, but in another year, once everything's ready and once everything's done, then there should be a performance benefit from attaching to the SCD5. And again, it's being implemented for multiple different Siemens products. So that will be its true benefit in the end. But for now, I mean, if like I said, you have to convert output files to use that right now. So there's absolutely, positively no reason to do that from Simcenter and Astran right now. But again, in a year or so, it should be almost full. It should be pretty well baked by then. So.
Okay, thanks. Yeah, and I think that answers, there were a couple different questions related to that. I think that answers all those. There was one on SAS. Brian, I think if you just want to tag up with Dan offline, I think that might be the most efficient way to answer that one. Next question is on response spectra capability. Does that always write an RS supply card, or is there a toggle to do it the old way?
I believe it always does it the new way now, but that's certainly something I can look into. I know it needed to write it the new way in order to support some of those new methods, but I will get back to you on that one.
Okay. Sorry, I'm reading these in real time. So when a solution type is listed on an analysis form, how does it toggle between modal and direct version of dynamic solution, since that's buried pretty deep in the analysis setup? Does it just assume direct until you check the modal box?
Essentially, yeah. I mean, if you use the next buttons to go through there, you always have to go to that dialog box anyways and choose modal, choose modal instead of direct. So basically, that's what you need to do in order for it. I mean, yes, by default, it's always set to direct. But then if you go change it to modal, that's when it knows to change it. And the same thing happens for transient analysis.
Okay, great. And I think that does it for all the questions. So yeah, I appreciate all of the responses here. I appreciate, Andy, you sticking with us. I know we're a little bit over,
Yeah.
But thanks for the great presentation. Thanks for your questions. And yeah, if anyone has follow-up questions, feel free to reach out to Andy or to reach out to us here at ATA. And yeah, we're just excited to start using these new features and continue the discussion. So thanks, everyone. Andy, do you have anything before we log off? No, if you feel like sending me just all the questions from the chat, Jonathan, I can take a look and see if there's anything more I can answer from that standpoint. Okay. Okay, cool. Well, thank you so much. And I hope everyone has a great afternoon. All right. Yeah. Thanks, everybody, for attending.